Hello, hello everyone. Um, so the next tutorial will be by Bargava Subramanian. He works at Cisco and does presumably data analysis there. He has a rather popular workshop that he conducts on using Pandas. Pandas is a really nice, very powerful library. In fact, we have two talks, two workshops that revolve around Pandas. The first is Bhargava's today, which will run you through the big picture of Pandas and what you can do with it. The second one is a more focused one about solving allotment problems for an hour tomorrow. So don't underestimate Pandas. If Pandas builds on top of NumPy, um, how many of you are the R programming language? Oh, nice. Okay. So you know that R has a data frame, right? Pandas is the data frame equivalent in the Python. So there's a lot of very powerful things you can do with data frames, and interface is really with data. So if you're doing data analysis of any kind, it's super useful. Right? Thank you.
Thank you. Okay, good afternoon, good evening everyone. I hope it's not good night yet. So, are you guys slightly awake now? I hope it remains that way. Voice is still very feeble, but I'll take that given that it's already 4:30. Okay, so some of the things that I want to cover today are this. So how many of you are still not comfortable with IPython notebook? Yeah, I'll just give, because that's the interface that we're going to use for the next couple of hours. I'll give a 5-minute demo and some shortcuts on how to use that. I'll give an introduction about what data analytics is, not from a programming perspective, but from a business perspective on how we would do that. And then we'll talk about why we need Pandas, and we'll do a lot of hands-on. And depending on time and interest, we'll see where to go from here. What next things that you can do to improve your data analytics skill set. So on the terminal, if you come here, and depending on the version that you have, if you have IPython 4, it's Jupyter Notebook. If you have a version before that, it's IPython Notebook. So I'm assuming that you guys know how to check what you have. If you do a pip freeze, you will know what all things that you have installed on your system. You can check what version of IPython you have. So this is 4 for me. So you can just do a pip freeze. If it's 3 point something, then you're better off using IPython Notebook. They are essentially the same. It's just a rebranding. Jupyter stands for Julia, Python, R. So in the same IDE, you can write code in all the 3 languages. Okay, so once you do that, it fires open a browser. So enter this within the folder that I'm hoping that you guys have the files that you downloaded. There's only two things that you need for today's workshop. 2 datasets, very exciting datasets that I generally use for my data analysis. For any workshop that I do, I use this. Use it across the world. This is the prices of weed in the US. So, know that this. Prabhu's not listening, so I can talk more about this. Okay, so this is for how you go. You go to the right hand top. You have various options. So you need to install kernels for Julia and R to work. So I use this, but just do Python 2. It opens an IDE for you. This is the cell where you enter all your text. Your text can either be a markdown. Markdown is just for formatting, so It's like a simpler version of HTML, so you can tell. Okay, so that's what it is. Default is code, so you can write code. Import pandas.cd and do shift enter, it executes it. The two ways to execute it, shift enter or control enter. If you do control enter, it remains the same cell. If you do a control enter, it remains there. If you do shift enter, the cursor comes to the next level. This is pretty much what you want to know. Everything else is the same as the IPython things that we worked on in the morning. So it's very similar to that. This is the only thing that you would need to know. Having said this, let me start with something about what data analysis in general. So there's a lot of data that gets generated now. That's like being a data scientist is the latest buzzword that you hear. The thing to remember is it's as much art as science. If you just have data, data will not tell anything to you. You have to ask the right questions for the data to tell you something. And asking the right questions is very, very, you have to be very systematic. It's an art. If it's something that can already be taught to the computer, then you would have already done it. So we really need human in the loop. And in general, we have a lot of complications in business. It's not very straightforward things to figure out. So we know a lot of unknowns. We have people with different opinions of the same set of outcome that you see. This is something you generally see. You have too much data or you have too little data. We call this tiny data problem. We face that a lot. And we still need to make meaningful decisions using that. Having said this, the kind of things that you can do with data can be broadly bucketed into these categories. First thing is just descriptive, telling what actually happened. This is just a transactional stuff, just summarizing and telling what actually happened. You're not making any inferences out of it. You're just seeing what happened. Next is to see exploratory. You do an exploratory analysis to figure out if there are any drivers, if you see any trends, things like that. When you see that, there are two important things that you see. One is you try to infer if something has happened or not. So the descriptive and exploratory part is where Pandas is just really dominant. That's why we use Pandas a lot. When you do inferential, you try to see if something is better than something else. So there are statistical techniques to do that. You use a lot of SciPy for that. The last major thing is predictive. So you want, based on the data that you have, you want to predict what will happen in the future. This is where all your machine learning, deep learning, and all this stuff gets into play. These two things are things which people generally expect based on your analysis. They want to know what caused what, which is the way my business is going, what are the drivers of my system, what happens if I change for example, what happens if I change the price of my product? Will I get more sales? Will I get less sales? Will this customer walk away from me? These are the kind of things that generally gets asked, and you will use a mix of all these things, so your descriptive, exploratory, inferential, and predictive to answer such kind of questions. Again, the most important thing that it started with is you need to know what kind of questions you want to ask. You can have any kind of data, but you need to know what questions you ask for you to figure out if you can use that or not. That's pretty much a motivation towards what data analysis is. We will see how we will do things then. Pandas. So one thing you should remember is in IPython, if you just close it like this, I'll just show you what happens. If you just close it like this, that will still be running. I didn't close it like that, right? So it's still occupying the memory. So you should quickly shut it down. And when you shut it down, it goes away. No longer in your RAM. Otherwise, your data gets accumulated in the RAM. Okay, so So there is a framework that I generally use for when you do data analysis. Basically, we call this process as acquire, refine, explore, model, insight. And that's a good framework for you to understand that when you want to do something, you first want to get data. And once you get data, you do some exploratory analysis to figure out what kind of stuff do you actually see, just visualizing it. Biologically, human beings are very good at understanding visualizations than numbers. And once you have that, you want to model and get insight. So that's generally the framework we see. I have a lot of content over this. You can look into it later on. I'm not going to cover that in. There's a whole lot of worked out code with assignments over there, so you can take it up as what you want to try it after this session. In this session, we will just do some parts of it. Okay. So what are some of the common data formats that you would generally see? You would have data in Excel file, in Excel format, in CSV. You would probably have it as a JSON format. You would probably have it in a relationship database. Python provides APIs to access data in any of these formats. For today's purpose, we will just stick to CSV. There are two CSVs that we would use. One is the census data that we have. It's not the latest census, it's 2013 census. It's got, for each state, it has the population, demographics information, what's the median rent, what's the median age, what's the per capita income, has those information. And we have, and someone took some lots of pain to build a crowdsourcing website. So what they do here is that when someone buys weed, they just need to go on to the website and tell if they bought high quality weed or medium quality weed or a low quality weed, and they need to tell how much they bought it for, and how much what's the quantity that they bought for, and how much they paid. And this gets aggregated at a daily level. So you know that on 1st January 2014, in the state of Alabama, the high quantity weed cost $339. 1st January, right? 1,000 people bought. Medium quantity $200. Still a lot of people bought. Not so many people bought low quality weed, and the cost was $150. So that's this is per ounce of weed. So there's data that runs. It's a time series data. It runs from 2013, 14, into 16. It's a website, so somebody is scraping the website, and the information is all available on GitHub. So you can just take it on. This is just a summarized view of what's there. So we'll take this and see if we can get some insights about how the prices vary across the states, and if we can make some sense out of this. And we'll use Pandas to do this. Okay. So we have seen numpy so far, right? What's the common issue that you think is there in numpy? Why do we need to go to Pandas? I mean, numpy also stores everything in numbers. You can do computations. All data sets? Okay. Any other answers? So no. So the thing is, one thing that has to be told is numerical Python, numpy, stores only numbers. Okay, but actual data also has text, has characters, has dates, has a wide variety of things. So numpy, while it's very fast, it assumes that your data format is homogeneous. If you see that example, I really liked it. So A over B, there was an example where everything, the answer was 0, 0, 0. It was because your entire, it's a matrix. Your matrix can have only a homogeneous data type. You cannot have data types of, cannot have different data types. And that's a very limiting factor because in reality, you would have integer variables, you will have floating point variables, you will have date columns. So this is a very classic example, right? So you have dates, text, quantities is just integers. It's not it's not have 0.4 of a person. Quantities, this is the actual price. The price will be floating point number and the date column. So you have different column types, but numpy you can have in only one particular format, and that's very limited. So you need an interface which can handle this and aid data analysis. Numpy first came in 2006. Travis Wilson made it, created it, but this came much later on. It came only in 2011, 2012, particularly after seeing how things are working in R and other places. Pandas was introduced which was data first approach. So you would see many of the things that it does is better than what's being done architecturally in R. So this was done by Wes McKinney. He used to work in Manhattan, and it was bugged with the library not supporting this in Python, and we built this. So having said this is that's one of the main motivations and why we need Pandas. And it has grown from where it started with, and now it supports the whole extremely powerful. So we just mentioned it. There are still a lot of things that we can do. So how would you import? So the first thing is you have to import it. Import Pandas as PD. This is the normal convention that you always import Pandas as PD. You enter it. The first thing I want to see is the version number that I have on the system. How do I see that? Of course, in the command prompt I can do a flip freeze. What can I do here? How do I run flip freeze from notebook? Huh? Yeah, this works. Okay, so I have that. Okay. If I need to execute command, I just want to do a quick freeze and see what all libraries I have. How do I do that? So when you do a bang at the start of the line, it executes the rest of the statement command line. Okay, so now you have a whole thing that you have. Okay. The interesting thing with Python is this returned as a list, so you can use this to see what versions you have and try to see that's the version that matches yours. Out of topic here, but that's something good to know, that if you do a bang and then if you type the command, that's something that gets executed. So this will give me a list of everything that's there. Okay, so now we have the first thing that we need to do is we need to read the data set. So the command to read the data set is cd. That's something called read CSV. So if I do a question mark here, what happens? It tells me what's the. It gives the help file right here itself. Which is huge help file. You can read it at your own pace. But we will first do. So if you do a tab, it tells me that that's a read right. So I'm going to read it. Are you guys able to import? So now I need to see the top rows. I just need to see the first 5 or the first I just want to see what's there in the data set. I don't want to open the entire data set. I don't know how much space it occupies. How do I do that? There is something called head. If you do head, it tells me that this is what it does. There's all these columns, and that's it. If I need to view the bottom, what do I do? Read dot tail. Okay, so head will give me the first 5. Tail will give me the last 5. So you can see that there is something called NAN. Let's see what's there in the Excel file itself for you to figure out what was. If you go to the last, it's telling NA, and it is so smart that it hasn't. If you use Python to read it, you could have read this column as text. But here it automatically figures out that this is a numeric column, and it has replaced it with NAN, not a number. Right? So these are missing values. It's a very common thing that you generally see in a data set, that you have values that are missing. How do I see what are the various columns that we have? So the thing to do is data frame dot columns. It lists down the column name. So it returns an array. Okay, this is an array. Okay, so now I want to know that what are the column types that it has imported, because we didn't explicitly tell what are the column types. We want Pandas automatically figure out what these column types are. We first need to figure out if the column types are correct or not. Right? No, we're typing new. Okay, so click. I showed, right? So we are going here, new Python 2. Okay, we are doing everything from scratch. Everything, yeah. Let me emphasize it again. That's what I told at the beginning. Whatever is already there, it's for you to go home and look into it and learn from it. We'll do everything from scratch now. It's a new file. Just open a new file. Things that we do might be there or might not be there. So just follow what you're doing here. We'll type everything from scratch here. Don't use any of the existing files. Anyone who doesn't have the data yet? Over there, all of you have the data? You don't have. I'll just go over whatever we have done so far. We did import Pandas as PD. We figured out what the version is. We figured out how to run a command, get output from command line, a bash command. Then we read the CSV. There are 2 files that you need. One is read.csv and the other thing is demographics_state.csv. These are fairly small size data sets. So once we did that, we saw what are the top rows and the tail. I'm just going to continue. If someone has an issue, please raise your hand. Okay, so we're going to see what are the various types of this stuff. So it's taken that the state is of object, everything else is float or int, and date is an object. So that's what it has imported as. So what issues do you see? What are the challenges here? The way it has imported. Is there any challenge at all? These are the column types that it has imported. Is it okay? How many of you have completed till here? Even before. Just do head, tail. Okay. How many of you have finished till this? This side? No? Okay, so question is, this is the way it tells that it is what the column types is. It's telling status object, this is float, int, float, int, float, int object. Do you see any challenges in the way it is imported? No? Yes? No. Do you see any challenges? No. I mean, so it has already. So if you can already see the data, right? The data looks very similar to how we loaded. The problem here is we want this to be a date column. So there is something called a date time. If you worked in Python, you know there's something called a date time object. So you want this to be a date time object, but it's assuming. Yeah. Can you hear me now? Go. To read the file, right? So this is where it starts. If we talk at this space, is it okay? Is this can't hear? Yes. Okay. Yes. No. What's your question? Fast? That is while reading the data. Pandas. Data. Right? Where is the data that you can get it from the net? There is the data. What did you download? Just right. because it is capital, right? It has to be small letters. Wait. Where is it? Do you have it in this same folder? Okay. This folder. Okay, once you've been line 41, there is a problem with the data. Please download the data again. Can you open the data? Of course, it's not right. It's not the data we have. Anyway, so you have to clone this. Okay, download it. Raw. But you can read the full, you can give it free for it. Yeah, now save it. Now save it and then upload it. So how many of you are still working on challenges? For everyone else, are you able to read the file so far? Okay. And then can you do a head and tail? Does it come like this? I mean, you have to give the right path wherever the file is. As long as to, I mean, you don't, yeah, I mean, wherever, yes. Relative to the current directory. Either you give an absolute path or from the relative to the current directory. So what I did is relative to the current directory. We'll give people working on issues for another 15 minutes. So if you have any questions, let me know. I can take questions now. Any questions on data analysis? Any questions? Yeah, some of you have saved it in a different place, so Can I continue? Okay. So now we have date. So there's a datetime object in Python, but it's imported as object. So we need to tell that that's a date object. So what we're going to do is, when we're going to tell, we're going to import it again. There is something called parse dates. So here, for this, we need to give the column where the date is. So the column is the last one. So how do we give that one? So this is the column, right? So there are a variety of ways to do it. Either we can give it as a column name, or I'm going to just give it as -1. Okay. So it gets, just takes it as the minus the last column. The indexing works the same way as what we saw in numpy in the morning. Okay. So now we can do columns, and you can see that it's taken as date. So it's taken as a datetime object. Okay. So now you have all the column names here. Those are the column names, exactly what we did before. Okay, now if you want to change the column name, what do we need to do? We have something called rename. Okay. First we'll figure out what the help cell is. It tells index column is something. Okay. We will just give. So one thing to note here is columns, if you look down, these are dictionaries. Okay, so it's internally storing everything as a dictionary. So for example, let's change high Q1 to high people Q1. Okay, so what we are going to do is it's going to be a dictionary. The key that I'm going to change is high Q1. And the new value that I'm going to do is okay. So it got changed. So now one thing that happens in Pandas for most of the functions is that it just returns a view. It doesn't change the data set. So if you want to change the data set, you need to add something called inplace equal to true. Okay. So when you do that, it permanently changes. Just to show that it hasn't changed before, I will show what it has. We ran that, but the column name didn't change. So we're going to replace that with inplace equal to true. And now if we do v.column, we have seen that the field name has changed. Okay. So the function to change the column name is just rename. And that's just a dictionary, so you just tell what are the key that you wanted, what is the key and what's the new value that you want us. Okay, so now there is something that you need to understand about the way Pandas gets stored. There are two ways in which you can identify, right? There are rows, there are columns. Rows have something called indices. This is the index. This is the 0th index. This is the first index. This is the second index. This is an index that uniquely refers that particular column. And you can verify that the index may not be unique. So that's another thing that Pandas allows you to do. That's an index which lets you do a faster access of a particular set of rows. And these are the columns that it refers. So when you tell index, it always refers to rows. And these are columns, column headers. So if you want to do select the first, they say the 15th to the 20th row, how would you do that? It's exactly what you did in numpy. So can someone tell what to do? th to 20th. That's it. So by default, it operates on the rows. It's exactly how numpy does. So it takes 15, 16, 17, 18, 19 all the way. So last one is, doesn't include. So 15 to 19 it returns. So if you want to select columns, how do you do? You pass the columns. So if there are multiple columns, how do I do? State and this wouldn't work because it needs to, okay. This is how you do. So within and you pass an array of columns that you want. So when you if the row and column indexes are the same and you pass something like this, what will it return? If the row index and the column names are the same, so here I am telling that read off, and I want this to be returned, right? Read 15th to 20th. And say, for example, the column names are 15, 16, 17, 18, 19, 20. What will it return? Okay, try it out. So you know how to rename the columns, and then try it out. But your answer is right. It will return the rows. Because first it looks for the index. The index is not there, then it goes and looks for the column. Okay. Let me just go over whatever we did again. So we read the file. We set the date to be minus from the last column, and we checked that the type is just return as a datetime object. We tried changing one of the column names. We tried renaming it. We learned what indexes and columns are in Pandas. We'll see why that's important in the next section. We just started looking by slicing the data, 15 to 20, state, IQ. So now we will do something where we will select both some set of rows and columns. Okay. So we are going to display the data in 10, 50, 20. This doesn't work because unhackable type. So there are different ways of. So it's not able to figure out. It's not able to figure out what. So we have to use something called. So let me. So there are a data set can be referred in predominantly 3 ways. So you can just have data frame. When you give something like this, it goes and operates on the row. When you do something there are 3 dominant things that's used. One is LOC, one is IX, one is ILOC. Okay. This one always takes care of absolute positioning of it. So if you tell ILOC of 1, 1 means that this is second row, second column. Okay, that's what it means. But when you do 1, 1, this 1, 1 and this 1, 1 are not the. Here it goes to the index which is 0.1 and it goes to the column which is 1. If there is no index of 1 or if there is no column of 1, this will return an error. Okay. So, I mean, we can try some of these examples based on this. So this one, 1, 1, what it does is that it first checks if there's a label. If it's not a label, then it returns the index. It's slightly complicated. I generally don't allow, but just to use if you're just beginning. Just stick to LOC because this is label based, it's absolute label based, what indexes mean, or you explicitly tell what row and column are. Once you get a feel of it, then you will really understand why one thing works at one place and the power of this. Do you want to see an example of why? Okay, we'll come to later on how to change the indexes. Now, we'll do some other stuff. We'll just to summarize the data. So we saw how to summarize. So this will give me all the states that's there, but now it's going to give me the states for all the columns. It's just data frame dot the column name. So you have auto completion. If you do a dot and tab, it will give you all the columns that are there in your data set. I'm just selecting state and listening for all the rows. Now I need to know only the unique ones. What do I do? It's very simple. I do it. Now this can be passed as an input to the next function. So there's something called unique, and it gives me. So if I do that, that's it. Very simple. Now I have all the unique things that's there. If I want to know how many unique states are there, what do I need to do? I will pass this to a count. This is an array. So So now what this returns let's construct it again. So this one returns an array, a normal array that we have in Python. So how do you find the length? So we did it this morning, right? It's just length of the array. You can see that there is 51 unique states that's there. There are other ways to do it too. Let's again what we saw in the morning and re-emphasizing. Those states, we saw this in the morning. So numpy, because this is a numpy array. So if you do a shape, it will give you what. So it has 51 rows and just one column. States of 10 to 14. So how do you do? Data frame of 10 to 15. That's one way of doing it. Okay. Any other way? So what happens if you do data frame dot LOC of 10 to 15? It also returns the same thing. Okay. There is a difference that you have to understand here. When you do this, it returns 10 to 15 on the labels. It omits the same. But when you do LOC, it includes that. So remember that there are small tricky things that like this that happens. In Python, generally the last one doesn't get added, but here it adds it. Okay. We talked about LOC, IX. So now we'll see. Okay. It returns the same thing. Okay. So there are small differences between IX and ILOC. Yes. LOC is label. So here it takes the label. So here it takes it goes wherever 10, 11, 12, 13, 14, 15 are. Okay. Okay. Let's. I need to do an example to show this. Okay. I'm creating a new copy of that data frame. Okay. This will give me what the indexes are. I'm going to tell. I think it's 3 indexes. Okay. I'm going to do a reindex. I'm going to reindex some. What is the so just going to do will not get, so what happens is that here is the index, this is the index, okay. So this index can be set to something else. For example, I can set the index to be, okay, now, and I change the index. I change the index to date. So now if you see the way it works, this is the date, this is the index. Okay. Will not work. Okay. Because there is no index 10 to 15. But on the old data set it works, because that has an index of 10 to 15. So this works on, so basically a row should be named that. When you do this, this particular row is identified by 2014-11. So you can, you are uniquely identifying a row by one particular number. You can think of this as the hash, right? So that's the hash for that particular row. Similarly, for a column, there's the name. It uniquely identifies it. Makes sense? Or so are people clear with this? Because this is something that you get to see a lot when you read a lot of Pandas code. Some people will use LOC, some people will use ILOC, some people use IX, some people won't use any of these things, and it's going to be a lot of confusion if you don't get this. Some things return all, the last number also, something doesn't return. For example, IX doesn't return the last one. You just saw that, right? IX returns. Sorry, ILOC doesn't return. These are just various ways to slice and dice the data. LOC is just means that it's based on index. It doesn't take absolute positioning. ILOC takes absolute positioning. You know, these two things, that's, you know, these are the only two ways that you would want to use when you start with. Either absolute positioning of your rows and columns, or if you know the names of your rows and columns, you can refer to them that way. So now we have this, right? Now we can see what we created this. That's new. Now I can do for this. Now I can pull, so this is what I told. Your index may not be unique. Now for all the rows with this index, it has returned it. So that's one of the advantages of this. Questions on this? And we are still looking into how. So unlike NumPy has just one way where you can slice and dice the data. So here you have these 4 ways to do slice and dice the data. And there are ways, and there is another way to set the data. None of these things will allow you to change the data. So that's another thing. You have to use another command to change the data if you want to change it. We can actually do that right now. Okay, so now we want to find, we'll come to the next point. Can we move on, or do you have questions? Shall we move on? Is this better? Yay. Okay, so so we want to figure out what are the data that's there in each one of the columns. So let's do that for each column, right? So now you can see, so there is something called count. It tells me how many data points are there. And it tells that LoQ has only 12,342, while the rest of the stuff, rest of the columns have 22,899. So they have some null values. So there are a couple of, so the one easy way to see number of the columns which, the rows which has null values, this we dot, we know that it's low q, right? So low q. So this will return what are the true and false. So now you can do read this will return everything that doesn't have, so if you look into the shape of it, it basically returns everything that doesn't have a null value. Okay, I'll let you. So what this does is it takes the column and it checks if it's null. If it's null, it returns true or false. So you know that towards the end there's a lot of true. So you want to know only those records for which it is, you want to know only the row, you want to get all the rows which are missing values. So you take the data set, you just subset it. So for each row it has a true or false. If it's false, it omits it, and only the true ones gets in. So you know that these are the columns which has, okay. Works for you. Anyone have questions on this? Okay, so now we know that it is there. Now we want to replace the missing values. Okay, so I mean missing values are not interesting things to look at because they distort your comparisons. There are, generally we want to set it to something. What are the common ways how we can replace the missing values? Yes? Please be loud. Replace them with 0. Good. Then by average value. Okay, good. Then we will never do that, but that's a very interesting. I don't have a chocolate. If I had, I would have given it to you. So his answer is we'll generate a random number between the minimum and maximum and we'll set it. So oh, it's there. Okay, I will actually give it to you for the most innovative answer that you have. Okay, so I'll tell you, this is a time series data. In time series data, the most common way to set it is to set it to the last available data point. For example, for 1 month or for 2 days, the data is not available. You set that value to the value that was last seen, and then you take it. So that's a very common way of doing it. First, we'll show you how to replace with 0. Okay, so we know that this is the one. We just did this, right? This is the way we constructed it. Low q is null. We know that this is the one. Dot will give me everything. Now I can set it to 0. Okay, we'll have to use. Okay, we will not do this. Okay, so I don't know why that doesn't work. I'll figure out how to do it. So the other way to do it is there is something called fill NA. Okay, you're going to fill if you do this, you can go all the way to the down, you know where your low quantity is, and it sets everything to the last seen number. Okay, now the problem that is here is that where is it? 161.30 is set to all the states, which is not correct. You want to set the value of last seen for that particular state. So first thing that you need to do is you need to first sort it. Columns, right? So you're going to do columns equal to state, date, in place equal to true. Otherwise, it returns only the view. Okay. So you're going to do sort on the columns. You're going to sort by state and then by date. So let's just see how it looks. So for one state, everything gets listed, and then from earliest available date it comes. Otherwise, previously, if you see, it was always returning one. It was sorted by state and not by date and state. Where are we? Okay, so you have sorted it, and then once you sorted it, you have to do a fill NA method equal to ffill. That's it. If you do it, it replaces it with the last seen value. So I am going to repeat this again. Until where were you guys coding? So where should I start it from again? No. Did you try this? Did you try sorting it? Now it's probably better. So you're going to sort it, and then once you sort it, you're going to fill it, and then you're going to tell in place equal to true. Okay? Makes sense? Once you do it, it's done. Now we will check the same thing, right? Now if you do, now you know that they all have the same number of things, which is what we did before. They didn't have, so now it has. So you know that it's there. All the missing values are replaced. Now for each state, you want to know how many records are there. Okay. They all have the same number. So this tells that for each state, how many records are present. You can also do it with a different column. You can do it with date. That will also tell that for each state you have for all the states. But I want to know what is the value, so I can also do a unique to see that, okay, everything is still the same. These are ways, so when you have a large data set, right, you cannot manually go and inspect. So you write something like this, you see the summary statistics to figure out if all the values are present, if some missing value is there, if the data makes sense or not. This is what you do with that. Questions so far? Okay, now we'll again, so now as of now we subselected only based on rows and columns, where we explicitly told 10th row to 15th row. Now we'll introduce conditions. For example, I want to have a data set which has only California data. So we'll do that's it. So you're going to tell state equals California. And if you do that, it just has data for California. Okay? Okay, so now we told that it's a date column. There are things that you can do with date column, right? So let's figure out what are the dates. There are a lot of date functions that's available both in Python, and Pandas supports all of them. The interesting thing that we need to figure out is if the dates are continuous or not. We have like 22,000 records. We don't know if the dates are continuous or if some dates, no, none of the states have values or not. We don't know that, right? So that's something that we need to figure out. Makes sense? So we'll do. That's it. Date.min, date.max. So we know that the minimum date was 2013, 27th of December, and the maximum date was 2015, June 11th. What's the number of, I mean, you can do some of these things to see if one date has more than one entry. So this is something that we have already done, so I'll let you guys do this. How do we do that? I want to know if any date has more than one entry. There are duplicate entries or not. How do I do that? Count of that particular date. How do I do that? Yeah, that's what I have done. Okay, then I want to know if there are duplicate entries in my, that's my question. I just want to know if there are duplicate entries or not. Yeah, I mean, if one particular date has two entries or not. So there are two instances that can happen with time series data. One is there could be a date can repeat. The other thing is dates can be missing. Okay, we'll solve. I know that there are dates missing. Okay, so we're going to solve that next. But first, before that, we'll figure out if there are dates which are repeating twice, because that's a bigger headache than, it's easy to fill missing values. As we saw, it's just one command. There are functions to do that, right? So we just did that, right? Column dot value count. It will tell me everything, and I'm going to do a unique of it, which is exactly what we did some time back. Now it tells that for every date, so what value counts gives is that for each particular date value, it tells how many times that value repeats. Okay, and I want to know the unique of it, and the unique is just 1. It's more like an interview question, but okay. Okay, so now we'll set, so we know that the dates are continuous, so we can easily set the index. How do we do? Set index to date, right? That's what we did. In place equal to true. Okay. So now date has become the index. Okay. Okay, now we need to figure out what are the dates that is there. A good way to do it is, there is something called pd.dateRange. It tells me that for the date that I have, this is going to okay, so the date column itself is not there, right? So the error comes because I've reset the index. If you look into, I mean, there is no date column here because that has become the index. So we need to create another 2. So now we have done it. So now we will take this and do it. That didn't work because it didn't have the dates because we set it to index. If that is set as index, it doesn't get listed as the column. So we copied it. Oh, what's happening here? Okay. So it gives the entire stuff as the range. So we'll set this to a particular value. So this gives me everything that starts from the minimum date to the maximum date. Now what we are going to do is we're going to do something called reindex. So if you read what reindex does, it creates a new index with missing values. So this is another way of doing missing values, right? So now you have dates as your index, and some of the dates are missing. But because dates are continuous, you can generate another column with everything continuous, and you can set that as your index. And whenever the corresponding match is not there, you're going to set that as 0. Makes sense? No? Okay. So, I mean, this is just a way to think, right? So you have dates from to all the way time in 2015. So you have dates here, but there are some dates which are missing here. Okay. So the approach that we are taking is that we will create one column, will generate something which generates all in this, which is what your function pd.dateRange gives. So this is like your similar to what you have like np.arange. They all generate values. Okay, we just saw range, right? Range of 10 gives you value between 0 to 9. Similarly, this also does the same thing, just that here you can have, this doesn't allow you to do floating point, this lets you do floating point. pd.dateRange is the same. You generate range numbers for dates, for the dates that you provide. So it's range on dates. So what you do is you generate a range from this to this, so that will have all the things, all your values. Now your date is your index. Index it. I'm going to reindex it with by new value that I created. And anything that is missing, if that value is missing, then I'm going to set that as 0. So this is another way of identifying missing values. This is very commonly used when you use time series data. Otherwise, when you have lots of series of data, it's very difficult to do anything more efficient than this. Pandas really lets you do. I haven't figured out, I haven't seen any other libraries which does in R or Julia or something similar like that. So you do a reindex. You reindex with IDX. We saw the help, right? What does it tell? It has an index. That's it. So you're going to do a fill value. So you need to use something called fill. What is the value that I'm going to set? If the date is not available, if the date is missing, then I'm going to set that as 0. Okay. Okay. Let's just do. The shape is 449.7. I'm going to do a reindexing. I did. Reindexing is always with. No, now it's 532. What was the data that it did? Okay, so we will do in case it will go to. It gets 532 by 7. I don't know why it's still showing as. But that's one of the ways how you do it. Okay. Okay. Let's do something, some way of summarizing. Okay. Let me do that. the most easiest way to get summary statistics is this. There's a function called describe. It tells me how many data points are there, what's the mean for each one on the data set, what's the standard deviation, minimum, maximum, and the various quartiles. It immediately tells me all the metrics. Just describe. Now this is okay. We'll do. So you can do mean for one particular row also. I mean, for example, you want to know. I mean, it's already here, right? So you want to subset it. I want to know for this state, for high quality, I want to know what the mean is. Very simple. So you just give conditions, and if I also need to give, I can also give one more condition now. This is how you add conditions inside and. So anything before 5th May 2014 and the state is New York, this is the value. So you add conditions to what's currently there. There's actually cool stuff that you can do. So this is the way you add columns to it. You do something called year equal to. So there is something called date time index of date. So what here it does is that you add a new column. That's it. It's so easy to add a column. There's something called date time index. It's telling that for the extract the date and convert it to year. It is not working because, can anyone of you tell now? It's too lost. Because it doesn't have a column called date. So we set it to index, right? So it is not there. So what you have to do, you have to reset the index. So once you do that, you do this there. And now you okay, something is broken and it's not the index. We'll skip this. I'll come to that later on. Merge two data frames. So we'll read in the other data set and see how the merge happens. Read CSV. So now you do a head. It has information on all the things. Are you able to read this data set? Okay, how many of you are still coding? One, two, three, four, five. Okay, I'll just tell you how to merge, and then how many of you have worked with SQL tables before? So it's something like this, right? So that's there also. If you can have multiple tables, you want to join them to create something. Here, this is the same thing. You have multiple files, and you want to combine them together to form a new thing. So there's something called pd.merge, and if you look into the help, it tells that you should give two data frames, and there are various ways to join it, like same as SQL. You can have inner join, div join, right join, outer join. What is the axis? What is the columns on which you want to join? So here we are going to do 2 columns. We're going to have equal to state. So we're doing an inner join. The problem is it doesn't return anything because if you look into it, this is all in small letter, and this is all in capital letter. The first thing that you want to do is you want to convert that into, it's again easy, state equal to 3.3.3. So if you just do this, it creates the lowercase version of it, and you set it to that particular value. That's it, you change. Now you take that value, you take the same code and you run. You basically run the same code. You merge left, right on the columns. Now it's merged, so it has all the columns. So in addition to your price, it also has your demographic information. People who are following, questions? Okay, that pretty much tells an overview of what you can do in Pandas. You can merge data set, you can slice, dice, you can change values, you can fill missing values. There are various ways on how to slice and dice. It's extremely powerful. And yeah, I mean, I'll let you guys ask questions or see what kind of stuff that you want to see. Maybe we can write a small code for that. Anything? Okay, thank you guys.
Okay, we're going to take a 5-minute break, and then we'll get back together and go over have our last talk, the BioPython, which is like 1 hour. So if we get back here minutes, we'll get out 5 minutes. 10 minutes? Okay. Yeah. Do people want to take a 10-minute break or a 5-minute break? How are you guys feeling energy-wise? 5? 10? 10? Okay, let's take a 10-minute break, and then we'll come back at the beginning of the hour and have one last hour of BioPython. And then that'll be it for today. Thanks.